Assalamualaikum and hello everyone. Welcome to Electrotechnology Lab for Electrical Engineering Studies at University Technology Mara. So today we will start with Module 2 titled Introduction to Resistor Color Code, Basic Instrument and Circuit Connection. In this module, you will learn how to identify resistor value using the color code, how to use multimeter, and how to set up simple circuit connection safely. So these are the foundation skills you need before moving on to more advanced experiment in electrical engineering. So let's get started. Before we begin the experiments, let's go through the experimental objective for this module 2. So at the end of this module, students should be able to use the multimeter and oscilloscope, build resistor circuits on breadboard using color codes, and use the function generator to produce the waveform. You will also practicing building the simple circuit prototypes and measuring resistance, current, and voltage. So these skills are the foundation for future electrical engineering experiments. To perform this experiment, let's first check the list of requirements. For the equipment, we will use a power supply, digital multimeter, an analog multimeter, an oscilloscope, and a function generator. For the component, we will need a breadboard, at least 6 resistors of different values, pliers or long nose pliers, and the jumper wire. So these two are essential to build the circuits, take measurement, and analyze the result. Let's continue with part A, resistor color coding scheme. Resistors are very common in circuit and their values are shown using the color bands. So these bands represent the resistance, tolerance, and sometimes temperature coefficients. So there are 3 types: 4-band code, which consists of 2 digits, a multiplier, and a tolerance band. 5-band codes, which consists of 3 digits, a multiplier, and a tolerance band. And 6-band code, same as 5-band but with an extra band for temperature coefficient. In the 4-band codes, the first two bands are digits, the third is the multiplier, and the fourth shows the tolerance. From the color table here, each color represents a digit from black, which is 0, to white, 9, and the multiplier is the power of 10, and the tolerance show the accuracies. So for example, gold means plus minus 5%. So by using this system, we can quickly find the value of any resistor in our experiment. So here is an example of how to read the 1 kilo ohm resistor color code with a color band: brown, black, red, and gold. The first band, brown, represents the digit 1. The second band, black, represents the digit 0. The third band, red, is the multiplier, which means multiply by 10 to the power of 2 or 100. And finally, the fourth band, gold, indicates the tolerance, which is plus minus 5%. So when we decode these, we will get 10 to the power of 2, which equal 1000 ohm or 1 kilo ohm with a tolerance of plus minus 5%. This means that the actual resistance value can vary between 950 ohms and 1050 ohms depending on the tolerance. So this simple method allows us to quickly determine the resistance of any resistor using the color band. Okay, next we continue with part B, multimeter familiarity and measurement. A digital multimeter shows reading on screen and can measure voltage, current, and resistance. Make sure the test leads are connected correctly and check their polarity. While for the analog multimeter, it uses a moving needle on a scale. It can measure both DC and AC voltage and current. For connection, always plug the test lead into the right terminals and observe its polarity. And please use the alligator clip if needed. So measurement is simple. For resistance, use the ohm function and connect across the resistor. For voltage, connect in parallel and select the voltage function. While for current, connect in series with the circuit, and finally switch off the meter after use to save the batteries. So with this step, you can confidently use both digital and analog multimeter. Moving on, we will discuss the connection of the breadboard. A breadboard lets us build the circuit quickly without soldering. So it has many rows and columns of holes where we can place components and wires. So the power rail at the top and the bottom are connected horizontally and are used for power and ground. So the middle section is connected vertically in groups of 5 holes with a center gap for ICs. If the power rail is split, so then you need to use a jumper wire to connect it. Right, this slide shows how circuits are arranged on a breadboard. So the schematic are on the left and the layout on the right. First, the parallel circuit for the 2.2 kilo ohm and 1 kilo ohm resistor are shared the same supply and ground rows. So both will get the same voltage. Next, the series parallel circuits, the 2.2 kilo ohm and 1 kilo ohm are in parallel, and this pair is connected in series with another 1 kilo ohm resistor. So the current flows through the resistor first, then split between the two in parallel. Finally, the common emitter amplifier circuit. The transistor is placed across the center gap with its base, collector and emitter on separate rows. So the collector connects to the positive VCC through a resistor, the emitter to ground through another resistor, and the base receives the input signal through a capacitor. Hence, this forms a common emitter amplifier for studying signal amplification. And that's conclude the introduction for Module 2. Students are required to carry out all 4 parts of the experiments and complete the results verification to ensure that all your measurements match the expected theoretical values. Check whether the calculated resistor values are agreed with the actual measured value and confirm that all circuit connections are made correctly. That's it for Module 2 session. Thank you for your attention and participation. I hope this session has helped you to build the essential skill needed for your future experiment. See you in the next module.